Hey guys, how's it going? Back with day 20 here. First off, just want to commend you guys. You did an awesome job working on that re-engagement with product rule, quotient rule, chain rule. Good job attacking that, getting a better hold on it so we can move on. Today I just want to do some practice with implicit differentiation, and we'll look at this tomorrow. So if you haven't watched day 19 yet, obviously watch that first. But here's just some more examples that I'll make up on the fly here. Okay, here's the first problem. Okay, so just a reminder on our rules for implicit differentiation. We go through and do the derivative of everything along the way. And if it's an x, we do the derivative as normal. If it's a y, we do the derivative as normal, then multiply by dy dx. So, working from left to right, I'm going to start with the derivative of 6x squared. That's just totally normal at 12x. And again, our goal here is find dy dx. Okay, when I come to the derivative of 3y squared, that derivative is going to be different because it's a y, right? So the derivative of 3y squared is going to be 6y, but then I also need to multiply by dy dx. I didn't have to do that when I did the derivative of 6x squared because it was an x. Okay, now I'm going to come to the derivative of negative 2y, right? That's linear, right? So the y is actually going to disappear here. The derivative of negative 2y is going to be negative 2, but then I still need to multiply by dy dx. So this is going to look like minus 2 dy dx. So the y disappeared, but we still have a dy dx. The y stayed in that 3y squared because the derivative of 3y squared is 6y. Both of them had dy dx's because we were doing the derivative of y. Okay, and don't forget about the other side of the equal sign. The derivative of 15 is 0. I'm going to solve for dy dx. I have two of them. So I'm going to choose to keep those on the left side. And I'm going to subtract this 12x over. And they're going to get 6y dy dx minus 2 dy dx equals negative 12x. And I'm going to factor out that dy dx. And I'm going to start doing this in one step here. I'm going to factoring out dy dx is going to leave me with dy dx parentheses 6y minus 2. But I'm going to factor that and divide by 6y minus 2 in the same step. And I'm going to get dy dx equals negative 12x over 6y minus 2. And now I just want to take a second and see if I can simplify this at all. I can't cancel out any x's or y's because not all three terms have them. But all three terms are divisible by 2. So I can divide everything by 2 and get negative 6x over 3y minus 1. Okay. The other way you might see this written, they might go through and divide by, instead of dividing by 2, they might divide by negative 2. I would create a positive 6x and on top and a negative 3y plus 1 on the bottom, which could also be written as 6x over 1 minus 3y. Key is, all of those answers are right. Negative 12x over 6y minus 2, negative 6x over 3y minus 1, 6x over negative 3y plus 1, and 6x over 1 minus 3y. All of those are equally correct. We just need to know that they're all the same, because on the multiple choice part of the test, where you don't know exactly what form they're going to put it in, so you need to be able to match their form. Okay, let's take a look at another one. Okay, here I have 6y squared minus 2xy plus 4y cubed equals 10x. And again, my goal here is I want to find dy dx. A couple of things I have to be careful of here. I have multiple y's. I end up with 3 y's in this thing. Okay, so anytime I do a derivative of y, I need to multiply by dy dx. We're kind of used to that. We also have a product rule here. We have function times function, and we know from our last unit that if we're doing the derivative of a function times another function, we must do derivative of the first times the second plus the first times the derivative of the second. Okay? We also have to be really careful here because of that minus in front of the 2xy. Okay, I'll show you what I mean. So going through and solving this, I'm going to start with the derivative of 6y squared. Well, that's going to be 12y dy dx. Again, that dy dx is because I did the derivative of y. Now, what I want you to think about, oftentimes students miss a sign here. I want you to think of the first term as negative 2x, and I want you to think of the second term as positive y. Okay? If you don't do that, then we're going to need to use parentheses. Okay, let me show it to you without parentheses first. So, this is my first, this is my second. So I'm going to start with the derivative of the first. The derivative of negative 2x is negative 2 times the second y. Because the derivative I did was of the x term, there's no dy dx needed here. Now people know the product rule is plus. Here's where you need to be careful. A lot of students will write plus 2x dy dx, okay? But that first term is still, we're thinking of it as a negative 2x. I do the derivative of the first times the second plus the first, but that first is still negative. It's still a negative 2x times the derivative of the second. The derivative of y is 1, but I need to take that 1 and multiply it by dy dx because I'm doing the derivative of y. Okay? So really, this overall sign here is going to change to a minus later on when I simplify. Okay? They both end up being minus, even though it's the product rule, and the product rule is plus. Because that first term is negative, it's going to override the plus and become minus. Okay? All right, let's finish out here. The derivative of 4y cubed will be plus 12y squared dy dx equals the derivative of 10x is 10. Okay. So rewriting this thing, what I really have here is 12y dy dx minus 2y minus 2x dy dx plus 12y squared dy dx equals 10. Okay, so what I see here is I have 3 different dy dx's showing up because I had 3 different y's in the original problem. So I'm going to keep those all on the same side of the equals. I'm just going to add that 2y to the other side. I'm going to get 12y dy dx minus 2x dy dx plus 12y squared dy dx equals 10 plus 2y. Okay. Again, just be careful when you're removing this to this side. Just remember that you do that by adding 2y. So if it's minus 2y on the left side, it's going to be plus 2y on the right side. Okay. I'm going to factor dy dx out of all 3 of those terms and divide over. Again, I'll do that in one. This one I'll show you it in 2 steps. What I'm doing is I'm factoring out dy dx, and I got 12y minus 2x plus 12y squared equals 10 plus 2y. Now I'm going to divide by 12y minus 2x plus 12y squared. And I'm going to get dy dx equals 10 plus 2y over 12y minus 2x plus 12y squared. Okay, and we're still having some struggles with simplifying. Okay, I can't cancel any x's or y's. It would have to be in all 5 terms. But that very first term in the numerator there doesn't have an x or a y. Okay, a lot of them have y's, but not all of them. But the one thing I can do here is divide everything by 2. So I'm going to get 5 plus y over 6y minus x plus 6y squared. There we have it. Okay, let's try one more example here. So here's what I have. 4x squared y plus 2x over y equals 10. Now, hopefully, as I was writing that, you're thinking about what kind of rules you might need. Rules you're going to need here would be the product rule for 4x squared times y. And you're also going to need the quotient rule here for 2x divided by y. Okay, so I'm going to use product rule for this one. And I'm going to use quotient rule for this one. Okay. So, doing this derivative, I'm thinking of this as my first and this as my second. So I do the derivative of the first times the second plus the first times the derivative of the second. Then I'm going to get 8xy plus 4x squared dy dx. Again, the derivative of y is 1, but excuse me, I need to multiply that 1 by dy dx. Okay, so that takes care of that first term, the derivative of 4x squared y. But now I need to take care of the second term, which is 2x over y. And that's going to be a quotient rule. So quotient rule says I do the derivative of the top times the bottom minus the top times the derivative of the bottom over the bottom squared. So here's what that's going to look like. The derivative of the top is 2 times the bottom is y minus the top times the derivative of the bottom, which is 1 dy dx, all divided by that bottom function squared. So I had to execute the quotient rule, okay, and follow the rules of implicit differentiation. And the derivative of 10 is 0. Okay, before I start solving this, I want to get this big fraction out of here. And what I'm going to do is I'm going to multiply both sides of the equation by what's in the denominator. So I'm going to multiply both sides by y squared. I have to now distribute this to all 3 terms. So I'm going to get 8xy times y squared will be 8xy cubed plus 4x squared y squared dy dx. By the way, in terms of like the order you write, I always put coefficients first, then x's, then y's, then dy dx's. And then multiplying that y squared by the big fraction over there is just going to cancel the y squareds, and it's going to leave it as plus 2y minus 2x dy dx. All right, so in a sense, this and this are canceling, so I just write the numerator in there. Equals, 0 times anything is 0, so we get 0 on this. Okay, now I have to get the dy dx's by themselves on the same side of the equal sign. Well, they already are. But here's the thing. I'm going to do this one a little bit differently than I've done the others. Instead of leaving the dy dx's alone and moving the 8xy cubed and the 2y, that's going to make both of those negative, and it's going to make 3 of the 4 terms negative here. So what I'm actually going to do is move both dy dx's to the other side. That will have 3 of the 4 terms be positive. That negative 2x dy dx is going to turn to positive 2x dy dx. And that positive 4x squared y squared dy dx is going to change to negative. Okay? So that's what I'm going to do. I'm going to move this over here, and I'm going to move this over here. This one I'm going to do with addition. This one I'm going to do with subtraction. So here's what I end up having. By doing it that way, I now have 3 of my 4 terms positive, rather than having 3 of my 4 terms negative. Okay? And I'm still going to factor out my dy dx here, and I'm going to divide. I'll do this in one step here. Factoring out my dy dx will leave 2x minus 4x squared y squared on the inside, and I'm going to divide that over. I'm going to get dy dx equals 8xy cubed plus 2y over 2x minus 4x squared y squared. And again, I have to think about simplifying here. You may be really tempted to cancel out some y's. You cannot do that because that 2x term does not have a y in it. We can't cancel out any x's either because of that 2y term that's on the top in the numerator on the right side. The only thing I can do here is everything divides by 2. I can write this as 4xy cubed plus y over x minus 2x squared y squared. And this will be my final answer. So this is a very algebraic manipulation heavy standard, okay? But we got to know the calculus on it too. All right, that's it for today. We'll practice this tomorrow in class. I'll talk to you guys later. 2 chains. Bye.